video I am going to explain application of Joule's heating effect. You have seen that when current is passing through a resistor, heat is produced. Now first application is electric heaters. Here are some of the home appliances where heating effect is used. Electric iron. Next, electric heater. Then electric toaster. In all these devices, heating element used is nichrome. Nichrome is an alloy of nickel and chromium. It is used because it has got high specific resistance. So you know what is specific resistance. So this is the expression for resistance. Resistance of a wire is directly proportional to its length and inversely proportional to the area of cross section. When specific resistance is very high, for getting a particular resistance, this length of the current element needed is very less. That is why we are using nichrome as the heating element in all these devices. Now let us see an example for electric heater. Electric heater of resistance 10 ohm is connected to a potential difference of 220 volt and immersed in water of 1 kg. Its temperature is to be increased from 30 degrees Celsius to 60 degrees Celsius. Question is, how long we have to pass current? That's the question. Now let us find the time required to raise the temperature from 30 degrees Celsius to 60 degrees Celsius for 1 kilogram of water. According to Joule's law of heating, H is equal to I square R T. Now heat produced can be calculated if you know the current. So current is potential difference divided by resistance as per Ohm's law. So now potential difference is 220 volt. Resistance of the heater is 10. So 22 ampere current is passing. So 22 square. Then resistance of the heater is 10 ohm. Then we don't know the time for which current is to be passed. If the temperature is to be raised from 30 degrees Celsius to 60 degrees Celsius. Now this is the heat produced in a time of T. That heat is used to increase the temperature of water. Then heat produced is used for heating the water. So for heat used by water is Ms delta T. This you might have studied in thermodynamics. Heat required to increase the temperature of a body from 1 degree Celsius is specific heat capacity. Specific heat capacity is the amount of heat required by 1 kilogram of the body for 1 degree increase. So now m kilogram through a temperature of delta T increase. This is the heat required, Ms delta T. M mass 1 kilogram. Specific heat capacity is 4200 for water. Specific heat capacity is 4200. Then increase in temperature, that is 60 minus 30, so 30. So this is the heat required to increase the temperature from 30 degree to 60 degree. Now this is the heat produced because of the current passing through the heater. Now you equate it 22 square into 10 into T is equal to 1 into 4200 into 30. So rearranging this, we can get the expression for time. Time is equal to 4200 into 30 divided by 4840. When you take this to the other side, then when you do this calculation, you will get 26.033 time. So it is, unit is seconds. So this is the time required to raise the temperature from 30 degree to 60 degree Celsius. Second use is electric fuses. Electric fuses are connected in series in a electric circuit to protect the electric devices when there are excessive currents. Copper wire will melt when it is current is around 35 ampere. But fuse wire is made up of an alloy of lead and tin. It will melt when current is 5 ampere. The one disadvantage of electric fuse is, once it is burnt due to excessive current, we have to replace it. So nowadays in electrical circuits, circuit breakers are used. If there is any excessive current, it will open, then after the correction it can be closed. Then next use is electric furnaces. To manufacture technologically important materials like steel, quartz, we are in need of electrical furnaces. To get a temperature of 1500 degrees Celsius, molybdenum nichrome wire is wound on a silicon tube. Carbon arc furnaces can produce a heat up to 3000 degrees Celsius. Next use is electric lamp. In an electric filament lamp, tungsten filament is kept inside a glass bulb. The disadvantage is, in this only 5% of the electrical energy is converted into light energy. Remaining part will be converted into heat. Tungsten filament will be heated to incandescence. Incandescence means emitting light at high temperature. These are the uses.